So hey guys, this is Dipesh, and in this particular video we'll be starting with our machine learning algorithms. More specifically, we'll be discussing about linear regression in this video. Also, this video is also one of the most important video in the entire course because I won't be just talking about any one particular algorithm, but I'll be talking about how almost all machine learning algorithms work in general. Okay, and also one note which I have also written in on the screen, that implementing these algorithms is very easy, but understanding them is very challenging. And it is true because in order to implement these machine learning algorithms, we already have a large number of tools. For example, in Python, we have scikit-learn package or library, which is very useful, and or we can easily implement these machine learning algorithms in like 3 or 4 lines of Python code. So it's not that hard. You don't worry about understanding the mechanics about the uh, don't worry about the programming part of these algorithms. Just try to get a high level overview about how these techniques or methods, these algorithms actually work. Okay, so let's get started. So before we dive into linear regression, let me tell you something about regression. What actually is regression, and when do we use this? What statement can be said to be a regression, or what kind of problem can be said to be regression? Now, some of you who have a statistics background or who have studied statistics may already know a lot about regression. So if you already know, you can directly skip to the coding part. Okay, so those of you who don't know, don't worry, I will be explaining everything in a very slow manner, so even a beginner can understand these things. Okay, uh, now in lecture 1 we saw that there are basically three types of machine learning. First is supervised machine learning, the second is unsupervised machine learning, and the third is reinforcement machine learning. And I also told you that each type of machine learning solves a particular type of problem. Okay, for example, supervised machine learning solves classification and regression problems, whereas unsupervised machine learning solves clustering problems. Now in this particular video we are looking at supervised machine learning. Okay, and more particularly we are looking at regression problem. Okay, now what exactly is a regression problem? Now a regression problem is when you have one or more independent variables and you want to predict one or more dependent variables. Okay, for an example would be, let's say let's say you have some data. For example, you have data about some employees in a company. Okay, you have their age, you have their experience, you know their job roles, etc., etc., and and you want to predict their salary. Okay, this kind of problem is called as basically called as regression. So basically whenever you're trying to predict any one particular continuous value, we call this problem a regression problem. So for example, if let's say if I wanted to predict salary of a person given their experience, now this particular problem statement can be said to be a regression problem because we are trying to predict a continuous variable called a salary. Okay, so this basically this kind of problem where where you use existing data to predict a continuous variable, variables like a person's age or the stock market price, etc., etc. This kind of problem statements are called as regression problems. Okay, a quick note that in a regression problem, the target variable or the dependent variable is always a continuous variable. Okay, so in on your screen you may be seeing a particular table. This table consists of 3 rows and 4 columns. Okay, now let's say you wanted to predict salary. Okay, now in this case salary will become the dependent variable, and the age, experience, and job will become the independent variables. All right, let me also mark them. The salary, age, and salary, no, the age, experience, and the job will become the independent variables, whereas salary will become a dependent variable. Okay, because we will be trying to predict the predict salary based on the data that we have on the person's age, experience, and job, right? And also see that the salary variable, okay, the dependent variable is a continuous variable. Okay, we can only call this a regression problem when the data, okay, the data that we are trying to predict is continuous. Okay, some examples would be a person's age. You know, a person's age is a continuous variable. For example, a the age can be, a person's age can be anything. You know, like for example, 7.1 year or 5.1 year, 3.2 years, something like that. So make sure that whenever you're trying to solve a regression problem or in a regression problem, the independent variable is a continuous variable. Now once you know what a regression problem is, the another very basic thing that you should know is what is a scatter plot. Okay, now I know this is very basic, but some of you may not be having the statistics background, so that's why I'm telling you what this is. Now a scatter plot is very easy. It just basically it is used to find the relationship between two variables. Okay, so on the x-axis you have your on the x-axis you have one variable, and on the y-axis you have another variable, and we use a scatter plot to find the relationship between these two variables. So also a quick note that the independent variable is always on the x-axis, you know. So for example, the the experience here, the experience variable is our independent variable, that's why it's on the x-axis, whereas the dependent variable, okay, or the variable that we are trying to predict is on the y-axis. So whenever you're drawing a scatter plot for a regression problem, make sure that you follow this thing. Okay, now the main reason why we draw a scatter plot is because we want to find the relationship among the variables. So for example, more specifically, when I say relationship among the variables, I mean correlation. Okay, now correlation is basically a phenomena. The basic correlation is basically a phenomena that describes the relationship among two variables. Okay, so for example, we can clearly see here that as the experience of a person increases, his salary also increases, you know. So there is a positive curve here. As the value of experience increases, as our increases, our y also increases. So there is a positive relationship here. Now this phenomena is we call this phenomena as correlation. Okay, now correlation is basically of two types: positive correlation and negative correlation. So what we are looking in front of us here is we can is positive correlation, because we can clearly see here that as a person's experience, okay, as the x-axis increases, the y-axis also increases. All right, so this phenomenon is called as positive correlation. Now what is negative correlation? Negative correlation is opposite of positive correlation. In negative correlation, if one variable is increasing, then the other variable is decreasing. Okay, this is something that happens when you have a negative correlation among your variables. All right, so this is basically the simplest kind of relationship that we want between our independent and dependent variable. Okay, there is also a third type of relationship called as no correlation. Okay, no correlation basically means like there is no relationship between the independent and dependent variable. Okay, like now in this case it becomes a normal scatter plot. Okay, it doesn't show the regular increasing or decreasing pattern here. All right, so this is a major relationship that we try to find among the independent and dependent variable. Okay, so whenever you will be trying to create a scatter plot, you have to basically see what if you are having any positive correlation or negative correlation among the variables. Now why am I saying this is because in a regression problem we always prefer to have a good correlation among the variables. Okay, because if there is a correlation, there is a increasing or decreasing pattern amongst the variable, then it becomes very easy for the machine learning algorithm to learn these patterns. Okay, because if uh, here we can clearly see that there is a increasing or a positive relationship between salary and experience. So it becomes very easy for our machine learning algorithm to model this data and to capture this pattern easily. Okay, but if there is no pattern, there is no correlation among our data, then it becomes very hard for our machine learning algorithm to learn more patterns in this data and make good predictions. Okay, also again, like for any regression problem, it is good that we have that the independent and dependent variables are correlated. Okay, also another point to note here is that whenever you are using linear regression, it is compulsory that there there is there should be at least some correlation among the independent and dependent variables. Now I will tell you why this is important. Okay, it is compulsory that the independent and dependent variables are correlated when using linear regression. It is because in linear regression, what we try to do is we try to draw a straight line among the through the data. Okay, you can see here we in linear regression we try to draw a straight line like this. Now I will tell you what this straight line means. Uh, but the main reason why we draw this kind of straight line is because we try to make our predictions using this straight line. Okay, so the more so whenever you are using linear regression, make sure that there is at least some a positive or negative correlation amongst your independent and dependent variable. Okay, if there is no correlation, among your independent and dependent variable, okay, the in that case don't use linear regression. Okay, let me tell you this again, that if there is no correlation among your independent and dependent variable, then don't use linear regression. Okay, then you have to use some other machine learning algorithm like decision tree or knn. We will talk about these algorithms in our further videos, but as of now just keep this in mind. Okay, then in order to use linear regression, it is very necessary that there is uh, either positive or negative correlation among your independent and dependent variable. All right, so uh, these are those are some basic things that you should know. Okay, before moving towards linear regression. Now let's talk about linear regression. What exactly is linear regression? Now linear regression is basically a machine learning algorithm or a technique or a method that we use to solve regression problems. All right, so for example, if we wanted to predict salary, okay, or if you wanted to predict someone's age given their height or given their uh, salary, something like that, in that case we use linear regression or any other regression algorithm. Okay, there are many algorithms that we can use to solve regression problems. So let me just go on Google and let me just type this, best regression algorithms. As you can see on my screen that there are many algorithms in order to solve regression problems. Algorithms like lasso regression, logistic regression, support vector machine, but the simplest one is linear regression. Okay, the most basic model, the most basic algorithm is linear regression. So linear regression is basically one of the many algorithms that we can use to solve the regression problems. Okay, now there are basically two versions of these algorithms. The one is called as simple linear regression and another is called as multiple linear regression. Now the a major difference between these two versions of these algorithms basically is basically in the number of independent and dependent variables they can handle. Okay, so whenever you have, let's say, one independent variable and one dependent variable, then you can use simple linear regression. But where in cases where you have multiple independent and dependent variables, then you have to use multiple linear regression. So for example, here you can see that here if we, let's say, if we want to predict salary given only experience, then in this case we can easily use simple linear regression. Okay, we can use simple linear regression because in this case the dependent variable is salary. Okay, we have only one dependent variable and our independent variable is experience, and we have the experience is the only independent variable. But in situations where we have many where we have many independent variables, so let's say we want to predict salary using age, experience and job role. Okay, in this case we have multiple independent variables like age, experience, job. Okay, we have total 3 independent variables and one dependent variables which is salary. Now in this case we won't be able to use simple linear regression. In that case we have to use multiple linear regression. Okay, now in this particular video what we will see is I will explain you simple linear regression, and at the end I will show you some Python code to implement simple linear regression. Okay, now I won't be discussing multiple linear regression yet because it needs some matrix multiplications and stuff, and it's a bit complex. Okay, I won't recommend you to see to go and see at multiple linear regression yet. It's better that you look at multiple linear regression after you have understood neural networks. Okay, because in neural networks we use a lot of matrix multiplication, and it becomes very easy to understand multiple linear regression afterwards. Okay, so also it is very easy to explain the fundamentals using simple linear regression because it's very easy. Okay, so yeah, let's get started with simple linear regression. Okay, so here is some data that I have created. This data is of some employees in a certain company. Now the each row basically represents data about a particular employee. Okay, now in simple linear regression, as I said you that we have only one independent variable and we have one dependent variable. So what we'll do is we'll pick an independent and dependent variable for our use case right now. So what I'll do is just forget that there is any age column here. Okay, just forget that, and also forget that there is any job column here. We'll use only the experience column and the salary column. Okay, and we'll see how we can use linear regression to create a machine learning algorithm which can predict the salary of an employee given his experience. Okay, so the first step in linear regression is creating a scatter plot of the independent and dependent variable. Okay. Here you can see that on the x-axis we have our independent variable, which is experience, and on the y-axis we have our dependent variable, which is salary. Okay. Now one quick note that this is just me giving a high level visualization of the problem. Okay. In real when we will code in real world case, we don't like create a scatter plot and try to draw a line or something like that. We do this using the line equation and all that stuff. Don't worry about it. As we go forward, I will explain it to you, but just keep this in mind that I'm just giving you a visualization of the algorithm. Okay, this is not how exactly we perform linear regression. We perform linear regression using mathematical formulas and stuff. Okay. Now in linear regression, what we do is we first create a scatter plot of all the points. Okay. And what we do is we draw a line of best fit. Okay, a line something like that, something like this. See here, let me draw this again. Yeah, so the first step in linear regression is draw a scatter plot, and second step is draw a line of best fit. Okay, so line of best fit, this blue line you see, this is called as line of best fit. Now what does this line of best fit do? Why have we drawn this line? Now the reason why we have drawn this line is because this line basically summarizes the entire data set here. Okay, you can see that there is a positive correlation among our two variables, and this line basically represents that relationship. We can easily see that as the experience increases, the salary is also increasing. So this line basically summarizes this entire data set, and this line is called as line of best fit. Now whenever we want to make any predictions, okay, so let's say you want to make predictions about, let's say you have, let's say your input is 10 years. Okay, let's say someone just ask your model what would be salary of a person whose experience is let's say 10 years. Okay, so in this case x would be 10, and we need to find our y. Okay, our x is 10 and we need to find our y. Now how do we find this? Now in order to find this, what we do is we just create a vertical line through the line of best fit. So let's assume that x is here, x is equal to 10 is here. Okay, so what we do is we just go vertically and intersect the line of best fit. Okay, we just intersect the line of best fit, and at whatever point this line of our vertical line intersects to the line of best fit, that is the at that point is our prediction. Okay, so our x is 10, we know that. We created a vertical line that touched the line of best fit. Now what we'll do is we'll again create a horizontal line through that point. Okay, and whatever would be the y value here, okay, whatever would be the y value here, let's say that the y value here is let's say y value here is 80,000. Okay, then that 80,000 is basically the prediction for our value. Okay, that 80,000 is basically a prediction for our value. So what we did was, for whatever value of x, all we have to do is just go and find that point on x-axis and draw a vertical line that touches the line of best fit, and again draw a horizontal line through that particular point, and wherever that line hits, that is your y-axis, that is your y prediction. Okay, Now I know this is too basic, and some of you may be thinking that why am I even explaining all this basic stuff? But it is necessary because some of you may not be from the statistical background or something. All right. So this is how we basically make predictions using linear regression. All we did was create a simple line, and just go and just create a vertical line that hits the line of best fit, and whatever value would be present at that particular point of intersection for y axis, that is our prediction. All right, it's not that hard, it's very easy. So this is how we basically make our predictions using linear regression. So, but now the main question is basically how do we decide this line? Like I just randomly let me clear all this stuff. Now I just randomly just drew this line, but how do we find the best line? Okay, how do you know that this line will give you the exact give you the best predictions? Why, we can also draw the line like this, you know like how do we judge which is the best line out of these two? you know so what we do is we make use of the equation of the line. Okay, now equation of the line, as we all know, is y is equal to mx plus c, where m is the slope of the line and x is the independent variable. Okay, and c is basically the intercept. So y is equal to mx plus c is the equation of this line of best fit. Okay, uh, uh, let me again write this here. Y is equal to mx plus c. This particular equation, this particular equation is the equation for this line of best fit. Okay, so y is equal to mx plus c, where y is our dependent variable and m is the slope of the line and c is basically the intercept of this line. All right, now what we do is, now here our independent variable is x. Okay, and dependent variable is y. So now what, when I say that we want to find the best line of fit, but we want to find the line of best fit, we can draw like infinite lines here. But how do we find the best line of the best line that will give us the most optimal predictions for our model? Now in that case, what we do is we make use of this equation of this line. Okay, we all know that the equation of any line is y is equal to mx plus c. So we can use this equation to find the best line of fit. All right. So now how do we use this equation? Okay, how do we use this equation to find the line of best fit? If you look closely, x is basically a variable, right? I mean, it is our responsibility to give the input as x. All right, so we don't need to worry about x, and y, we also don't need to worry about y because we are trying to predict y. Y is a dependent variable. Okay, now the only two things that are remaining are the slope, which is m, and the intercept, which is c. Now uh, these two things, okay, m and c, are our parameters. Okay, because for each line, because the only thing, because if we draw multiple lines here, all right, multiple lines here, the only thing that is changing here is the slope and the intercept. Okay, the only thing that is changing here is the slope and the intercept. So when I say that we want to find we want to find the line of best fit, I'm saying that we want to find the most optimal parameters here. Okay, we want to find the most optimal value for m and C. Okay, we want to find the most optimal parameters for M and C. We want to find the most optimal parameters for M and C. Basically, we want to find the values for the slope and the intercept such that they will give us the most optimal predictions. Okay, so how do you do that? How do you find the values for M and C? I mean, again, like there can be like infinite set of values that we can use here. So how do you find the most how do we even, like, where do we even start for these values? Before we begin, like, in order to explain you how we can do this, I need to first explain you two very important concepts in machine learning. The, that is the cost function and the gradient descent algorithm. Okay, so there are two very important things that I will be explaining you, which is first is the cost function or the loss function, which cost function is also called as the loss function, and the second thing is the gradient descent algorithm. Okay, and these two are basically the most fundamental parts of any machine learning algorithm. No matter where you go, no matter how complex or how simple your algorithm is, you will always have a loss function, and you will always use gradient descent in that particular algorithm. Okay, so yeah, first let me explain you what do we mean by cost function or loss function. So basically, the cost function or the loss function is a method of evaluating how well your machine learning model is doing, or basically how well the machine learning algorithm is predicting the values correctly. Okay, so loss function is basically just a function. Okay, just like it's basically a mathematical function whose value basically increases if our model is not doing well. Okay, I will repeat this again. Loss function is a mathematical function whose value will increase if our model or machine learning algorithm is not predicting correct values. Okay, if our model is not doing performing great or not predicting correct values, then our loss will be very high. Okay, contrary to that, if our machine learning algorithm or machine learning model is performing very well, then in that case our loss would be at the minimum. Okay, so this is what we call as basically cost function or loss function is a mathematical function that outputs a single value. Okay, it outputs a single number representing how well our model is predicting the values. So a lower cost is always preferable. Okay, basically the goal of training any machine learning model, okay, the goal of training any machine learning model is to lower this loss. Okay, is to lower the loss function or the cost function. Okay, basically they are the same thing. Okay, loss and cost. It should be also very obvious from the naming. By loss we always try to basically keep our losses at the minimum. All right, so so that's pretty obvious here. So again, whenever we will be training a machine learning algorithm, our goal is to train the model to lower the loss of the loss function. Okay, now what exactly is like, now there are basically different types of loss functions depending on your problem. So for example, for regression problems, here you can see on the screen, for regression problems we use a particular type of loss function called as mean squared error. Okay, it is basically used only for regression problems, whereas for other types of problems, for problems like classification or clustering, we have different kinds of loss functions there. Okay, so again, loss function is what? Loss function gives us is a mathematical function that outputs a single value, which basically it's kind of like a metric. Okay, it tells us how well our machine learning model is doing or not, and our main goal is to lower this loss function. The lower this value would be, the better it is for us. It basically represents, a lower value represents that our model is doing very good, and our model is predicting correct values. A higher loss value would mean that our model is not predicting correct values. Okay, now once I explain you how basically a loss is calculated, it would be very obvious to you, because the loss function or cost function is not very hard. Since we are doing a regression problem, I will explain you how we can basically calculate the loss for a regression problem. So the most common function, the most common loss function for a regression problem is mean squared error. Okay, there are also other kinds of loss function like binary cross entropy or hinge loss, Huber loss. You know, for every machine learning problem, there are different kinds of machine like loss functions. Okay, so for this, since we are doing simple linear regression, I will look at the most popular loss function called as mean squared error. You may be seeing the formula in front of you here. The formula is not that hard. So for example, let's say the formula is basically very easy. Here the y predicted represents the value which is predicted by the machine learning algorithm, whereas this y represents the actual value of that particular thing, particular data. So for example, here let's say we gave the machine linear regression model the experience value of 3.5 years. Now we know that the salary, the true value of y is 51,500. Okay, we know this is the true value. Now let's say that the model predicted that the value is somewhere around 41,500. Okay, this is basically the predicted value. Let's say that this is predicted value. Okay, so this is what the loss function represents. Okay, the true value, the loss function basically here, what it says is, for all the rows, for all our samples in our data set, what you do is it basically is a average of the different squared of the difference between the true value and the predicted value. Okay, so now let's say okay, so just like we had we predicted the value for the first row, let's assume that we made the predictions for all the rows. Okay, we made the predictions for all the rows, and these are the true values and these are the predicted values. Now in this case, how do we calculate the mean square error? If we go according to the formula, then what we have to do is we have to basically first find the square of the difference between the actual value and the predicted value for all the samples. So here you can see that what we are doing is, the first true value is 3.5 and the first predicted value is 1.5. So what we do is we find their difference and we square it, and we do the same thing for all these samples. Okay, all the rows, and at the end what we have to do is we have to take the average. Since we have four samples, we'll divide it by 4. Okay, and the loss that we got after calculating this is 1.285, which is still pretty good since it is close to 0. In what we want to do is we want to have this value as close to 0 as possible. All right. So the loss function is kind of like a metric that you use that we use to judge how well our algorithm or the machine learning model is doing. Okay. So this is basically an example of how we can calculate the mean squared error. Okay, mean square error is basically the most common loss function for regression problems. All right. So now what we know is, so basically what we do is we optimize our machine learning algorithm to lower the cost. Okay, we train our algorithm, machine learning algorithm, to lower this loss function. Okay, so now let's say that what we can do is, let's we can now we know that we know how to judge which line is better. Okay, so for example, I can draw this line and I can draw this line. Okay, out of these two lines, in order to find out which line is better, what I can do is I can make predictions using both these lines, and I can calculate the loss function. I can calculate the loss mean squared error for both of these lines. Now the best line would be that line which gives me the lowest cost. Okay, the line which gives me the lowest cost. So now we know that now we have a way to judge these lines. We can find out that which line is better and which line is not better. Okay, but how do we how now this again doesn't answer our question that now again we have infinite set of values that we can use for M and C, right? How do we find the most optimal value for M and C? Now this is where gradient descent comes in. Okay, this is where gradient descent basically comes in. Okay, now gradient descent is basically the most common. You will find this algorithm is used in almost all machine learning problems. Okay, so it's very important that you understand this algorithm. Okay, you basically the main what this algorithm does is uh, find the most optimal parameter values for us. Okay, so in our case we have two parameters, M and C. So what we can do is we can use gradient descent in order to find the most optimal values for us. Okay, so let me just explain you the official definition. So descent, it is an optimization algorithm which is commonly used to train machine learning models and neural networks. Training data helps these models learn over time, and the cost function within gradient descent specifically acts as a barometer, gauging its accuracy with each iteration of parameter updates. In simple words, gradient descent helps us find the most optimal parameter values which give the lowest loss function values. Now it would be pretty obvious just from the definition. Gradient descent is basically a method or a algorithm which helps us find the optimal values for our parameters which give the lowest loss function. Okay, when I said that we wanted to find M and C, I also mentioned that there are infinite values set of values that we can use for M and C. But how do we choose the most optimal values for M and C? Now in that case, we only choose those values that will give us the most optimal, give us the lowest cost function as possible. Okay, let me repeat this again. We choose those values that give us the lowest value for the loss function. Okay, now in order to find those values that give us the lowest cost function or the lowest loss function, we use gradient descent. All right, in order to find the values for the parameters that give us the lowest cost lowest value for our loss function, we use gradient descent. Okay, so that was basically what gradient descent is, and now we'll go deep into how gradient descent actually works. Okay, now this is again a high level overview of how gradient descent works, because if I was about if I were to actually go in depth and tell you exactly how all these things work, it would become a bit complex, and at this stage it's pretty unnecessary. Okay, when we'll go into neural networks, I'm pretty sure to we'll go in more depth and learn more about this algorithm. Okay, at this stage, don't worry about how this works. Okay, just get an idea about what is happening here. Okay, uh, uh, don't try to understand everything. Okay, you will probably have to watch this video like 3 or 4 times before you actually get all these things. So let's see how gradient descent actually works. Okay, now gradient descent, basically there are 3 to 4 steps in gradient descent. Okay, now this is again a high level overview. Don't worry about like don't try to understand everything here. Just get a high level overview of what I'm saying here. Now the first step is set all the parameters to 0 at start. So basically what we do is we have these two parameters. As of now, I will only consider M. Okay, uh, forget about C. Okay, let's assume we have only M. Okay, we have only one parameter. So what we'll do is we'll set M is equal to 0. Okay, we'll set M is equal to 0. Now what we'll do is we'll calculate the loss function for our we'll calculate the loss function for our algorithm, for a model. Okay, now how do we calculate the loss function? What we do is we try to predict all the values. Okay, we try to predict all the values that we have. We try to, for example, in this case we are trying to predict salary given experience. So what we do is we give all the salary samples, we give all this salary data to the model, and we tell the model to predict salaries. Okay, predict the values for salaries. Okay, but we also know that what is the true value for salary. Okay, we do know that what are the true values for our salary. We are just trying to calculate the loss here. Okay, so after the model has predicted the values for salary, we have the true values for salary, and then we'll have the predicted values for the salary. So using these two variables, we calculate the loss function, which is mean squared error in this case. Okay, so we set the values for the parameters at 0. It's not necessary that we only start at 0. Okay, but in most cases we start the parameter values at 0. Okay, once we start the parameters at some value, we calculate the loss. Now the second rule is we update once the loss is calculated. What you do is we update the parameter values using the update formula. Okay, now update formula is I will tell you about update formula just in a minute, but before we get into that, let me explain all the steps here. Okay, so we have followed the first step, which is to start the parameters at some value. Most commonly it is 0. The second step is to calculate the loss. Okay, the second thing is to calculate the loss. Now we have calculated the loss and we got, let's assume we got some numerical value here. Now the third step would be to update the parameters using the update formula. Now what this update formula is? It is the basic formula. You can see here. It is the basic formula in order to update update a new parameter for us. Okay, because at the start we initialized our parameters at some random value, right? And that gave us a loss. Okay, let's assume the loss is 1000, and what we want to do is we want to go towards 0. We want this loss to be close to 0. So what we'll do is we'll change this we'll change this parameter. Now how do we change this parameter again? We change this parameter by using the update formula rule. Okay, now once this update formula once we apply this update formula on our parameter value will again change. Now let's say that the parameter value is something like 0.7. Okay, now once we have assigned a new value to our parameter, what we'll do is we'll repeat the second and the third step again. Okay, now again, like once the parameter value is set, what we'll do is we'll try to we'll compute the loss again. Okay, now the loss would be a bit lower. Previously it was 1000. Now it may be somewhere around 800. 800. So now again what we'll do is we'll update this parameter using the update formula, and we'll keep on doing this until this loss function basically reaches a global minima. Okay, a global minima or gets very close to 0. Now if we create a plot of our loss function, okay, of our losses, okay, at each iteration, we are getting a loss value, right? At each iteration we are getting a loss value, and so basically when we started at 0, we got some loss value. Then again, when our parameter value changed a bit, we again got a loss value, right? If we create a plot of these values, we'll get a plot like something like this. Okay, something like this, something like a cup. Okay, what we want to do is we want to reach at the globe. We want to find the parameter value, which is m in our case right now. We'll choose the parameter value for which the loss function is the minimal. Okay, minimum. So you can see that as we basically as we update the value of a parameter, as we perform more and more iterations, our loss is basically decreasing. Our loss is decreasing. So what we want is, after few iterations, our loss will reach at a global minimum, and we want to choose the parameter for which this value is the lowest. Okay, this value is the lowest. So this is what basically gradient descent is. We try to optimize, we try to update our parameters in such a way that they will decrease the loss function. Okay, and we want to choose the value for a parameter which gives us a global minimum loss. Okay, a global minimum loss. So basically, rather than randomly choosing values for our parameter, we are giving a direction to our values using gradient descent. Now this is also very important, the word direction, because if you look at the update formula, you will see one very important thing, which is the derivative. Now some of you who have studied calculus, you may get this thing. Now let's say that this w represents our parameter, okay, and this derivative basically this particular piece represents the derivative of loss function with respect to the parameter. In our case, the parameter is m, okay, in our case the parameter is m, and our loss function is mean squared error. So this derivative is basically, this derivative represents this piece basically represents the derivative of mean squared error with respect to with respect to the m parameter, okay, and this alpha basically represents learning rate, okay. Now this basically is the updation rule. We use this rule to update parameters in machine learning, okay. This is not specific to linear regression. This formula is basically a universal formula which we use in almost all machine learning algorithms, even in neural networks, okay. So the main reason that I use the word direction, okay, emphasis on this word direction, okay, because as I said that there are infinite possibilities, infinite set of values that we can use for our m parameter here, and there are infinite lines that we can put here, but we want only those values for which the loss function is the minimum. We want only one value for which the loss function is minimum, okay. And we also want a particular, basically we don't want to randomly select values, okay. We want a particular direction in order to select the values. So that's why we basically start at 0, okay, and as the iterations increase, we use the updation formula to update the value of that parameter. Now updating the formula, now how this works is basically the new value for the parameter is equal to the old value of parameter minus learning rate minus the okay, I'm sorry, let me repeat this again. New value for the parameter is equal to the old value of parameter minus the sum minus the multiplication of learning rate and the derivative of the loss function with respect to the parameter m, okay. Now don't worry if you don't get it, because I can create a whole video just explaining how this formula works and how this formula basically gets us the global minima, okay. But that will only make the things more complex, okay. Don't worry about this. Just keep in mind that we use this formula to update the parameters, okay. The derivative basically plays a very major role in deciding how we change what direction do we change the values, okay. And this alpha is basically constant, okay. We call this alpha as learning rate. It's basically constant. Now it doesn't change its value as the iteration goes. It's a constant value. Let me give you an example how basically the value of our parameter basically how the value of our parameter will basically change, okay. So now let's say that our current value of m is 0, okay, and our learning rate is 0.01. Also the most common value for this alpha is 0.01, okay. This learning rate basically defines how fast our algorithm will learn, okay. So basically the most common value is 0.01. Okay, now let's say that the value for our m is 0 and our learning rate is 0.01, and also that the derivative of the loss function with respect to m is minus 24. Now using this formula, if we calculate the new value of m, okay, if we calculate the new value of m, then the new value of m would be 0.24. If you see that, if you see here, m is equal to m minus learning rate, which is 0.01 multiplied by minus 24. Okay, this minus 24 is basically a derivative. This 0.01 is the learning rate, and the m is basically the current value of m. So the new value of m would be 0.24. Okay, now again, like we do this thing for many, like thousands of iterations in order to get the most optimal value for m, which will give the most lowest loss. Okay, so basically it's very simple. We have a loss function and we try to reduce it by trying a large number of different parameter values. Okay, as of now, just keep this thing in mind. Okay, now I guess you should have at least a very basic understanding of how a machine learning algorithm works, right? Now what we'll do is we will start with linear regression in Python. Okay, I will show you how we can basically implement simple linear regression in Python. So yeah, before we go, let me also explain you how we even find the line here. Okay, for example, now once we know now we know that how we can find the most optimal parameter, right? We know that how we can find the most optimal parameter for our machine learning algorithm, right? So all we have to do is we have to use gradient descent. We can basically use gradient descent to find the most optimal value for m and c, right? And once we find the most optimal value for m and c, all we have to do is we have to just insert the values for an independent variable inside this equation. Okay, by finding the most optimal values for m and c, what we did was we found the most optimal line here. Okay, we found the most optimal line of best fit here for our scatter plot. Okay, now all we have to do is just plug in the values here, because y is basically unknown, right? We know m. Once we run gradient descent, we'll know m, and x is basically a variable which we have to give to the model. Okay, so for example, if let's say our m is 0.4, right? And our x is, let's say, 5 years. We want to find the salary of a person with 5 years, and our intercept is basically, let's say, 10, right? Now all we have to do is just compute this simple formula, right? All we have to do is multiply this 0.4 with 5 and add 10 to it, and we will get our y value. That is our prediction. So this is basically how linear regression works in theory. Okay, like this is how basically in general any machine learning algorithm that we will learn in our further videos works. Okay, all machine learning algorithms have a loss function, and they use gradient descent to learn their parameters. All right, now let's implement linear regression, simple linear regression using Python.